Okay, example 3. Solve the following equation completely. I picked this one because it's actually fairly easy to take a look at all possible rational zeros. So if I look at the factors of my constant over the factors of my leading coefficient, I get plus or minus 1 and 5 over plus or minus 1, 3, and 9. And I am going to pick 5 because of that. I'm having a hard time seeing that the other possible zeros, especially the fraction zeros, are going to work out well. But let's throw in a 5 and see what happens. Okay, 5 times 9 is 45. All right, I already know I have a problem because I add 39 and 45, I'm going to get a number over 80. And then I'm going to multiply it by 5. And I'm going to get a bigger positive number. So this is not going to work. So let's try negative 5. And let's just restart the process. Okay, negative 5 times 9. That gives me a negative 45. And that's a whole lot closer. It keeps the number smaller, which tends to lead to solutions. So I get a negative 6, I get a positive 30, positive 1, and negative 5 times positive 1 is negative 5. So I do have a 0 at negative 5. And when I look at the remaining quadratic, I get 9x squared minus 6x plus 1. And I know it's not factorable. There's not two numbers that multiply. Well, even if I think of AC factoring, well, wait a second. Actually, A is a perfect square, and B is a perfect square, and C is a perfect square. So let's just try taking square roots. 3x, 3x, and square root of 1 is 1, and because the 6 is negative, I'm going to try this. And it looks like this is going to work. Because if I do all 4 multiplications, the 2 multiplications that give me my x terms give me a negative 3x and another negative 3x. That's negative 6x. So I have all of my solutions. I could factor that one. So solve the following. My zeros are at negative 5. And when I solve 3x minus 1 equals 0, I get 1/3. 1/3 and 1/3, or 1/3 with a multiplicity of 2. Not much. Okay. Example 4, solve the following equation completely if x minus 4 is a factor. So they gave us a hint. We're going to do our synthetic division, and we're going to start with positive 4 as a 0. And then see what we have left. Four times 9 is 36. Yeah. We got a 0. And it looks like this one is also a perfect square trinomial. X plus 3, x plus 3. So our zeros are at 4, negative 3, or negative 3 with a multiplicity of 2. Okay, I am going to stop the video here because this next example is going to take a while.